Okay, this is day 1 for 3.6. This is IM1, and we're going to be talking about translations, and that is it. So translations. We're going to be talking about other things on other days. So in the exploration 1 in your journal, you see they told you to graph these lines. So I didn't want to take the time to do that because I wanted you to observe the lines after they're graphed. This is the original line, and this is after it's graphed. Notice the change in the function. So what do you think happened here? So I can look at it a couple of different ways. I can say 1, 2, 3, 4. Looks like it moved to the left 4. Or I could look at it another way, and I could say, oh, I can see it went up 1, 2, 3, 4. Or 1, 2, 3, 4. So either way, it moved 4. But I can't really tell, and that's one of the problems with teaching with linear lines about translations. So we're going to go through some very specific steps that will help you understand that better. So again, let's look at number 2, or B. This is the basic function, and I moved 2. Whether I moved up 2 or over 2, I don't know, but I moved 2. Over here, here's the original function. This time I either moved right 2 or down 2. Okay, and on this one I either moved right 4 or I moved down 4. So that's what I mainly wanted you to notice, was that it shows you how much of a movement it made. You might notice that a negative number means go right, and a positive number means go left for a horizontal movement. Okay, if you have a vertical movement, which is up and down, then the plus a negative number means down, and a positive number would mean up. Okay, and we'll talk about those in a minute. Okay, all right, so here it is in your book. You'll see this on page 87 in your journal. It explains in their way all the different changes, and you can look through that and get yourself familiar with that. Okay, so the thing I wanted to warn you about, I just told you about, was moving things. So let's say I did f of x equals x plus 2. Well, I'm not even sure what that's telling me to do. So what I want you to notice is that if it's not affecting just the x, I'm going to be going up. So let's go up 2. I'm going to pick a few points, and I just keep doing that, and then I make my line. I can go up to here. It's kind of hard to see the graph. There we go. So, and then I would connect that line. Okay. So if I had a line marked, a point marked, on my original graph, let's say I had this point, and I said this is the corresponding point on my new graph, then I would very definitely know that I went up 2. Okay, so this was a vertical movement. If I wrote the equation like this, as soon as I put it in parentheses, it's telling me that it's only affecting the x. And when I do that, that means it's a horizontal movement. Now, the funny thing about horizontal is it's not logical. So we have to remember that if it's x plus 2, we're going to go left 2. And we're not going to worry about that right now. We're just going to memorize the rule. It'll all make sense once you get into IM2. But for now, we're just going to memorize the rule. Plus in a horizontal means left. Plus in a vertical means up. Okay? So we're going to go, I'm going to change colors here so you can see the difference. So I'm going to go left 2, and I'm going to start with this point right here. 1, 2. And so if I had this corresponding points, you could definitely see that I went left 2. And by having it in parentheses, that's telling me that I'm doing a horizontal movement. But if you noticed, I could do that for every point, and I'd end up with the exact same line. That's why using horizontal lines to teach translations is kind of confusing. Okay? So you have to have a corresponding point to show up and down or left and right with a linear equation. Okay? All right, so here is showing you horizontal translation. So notice here we have, this is our basic function, and If we put a minus on it, that means go right 2. So we're going to go 1, 2. We're going to take a bunch of points. Notice I have a corresponding point here to show me that. So that's really good. Then when I have minus 3, that's telling me to go left 3. And so I would go 1, 2, 3. There's my corresponding point there. And if I was going to write this the way I should for a horizontal translation, it should be y equals parentheses x plus 3. That would definitely tell you it's horizontal. And this one should be y equals parentheses x minus 2. Okay? It's a little easier to see what they're talking about when they talk about the argument. So the argument is your x, or your variable, when you see a quadratic. So the main equation for a quadratic is just that f of x equals x squared. If we're going to go left 2, then we put the 2 inside the parentheses, and then the square goes on the outside. Notice it's only affecting the argument, the x. The x is the argument. So in this case, it's only affecting the x. Same with this one, which is saying go right 3. It's only affecting the argument, so it's in the parentheses with the argument, and the square gets left outside. Okay, so it's a little bit easier with quadratics and exponential to see the changes. So here's the argument. It's the variable on which the function operates. So here is an example. So this is my basic function of an exponential. Okay, you should be able to recognize that by now. It's when x is the exponent. And if I'm going to show, this is showing how to write the function in terms of the basic function. So I'm saying take the basic function and go left 3. Okay, that is telling you in terms of the basic function. Okay, now when I want to write the new equation, which is a whole different thing, so I'm going to write my new equation, and my new equation already has a name. It's the w of x, well, actually the v of x, but we're going back up to here. So the v of x, and I would write it as 2, and then instead of just my x being alone up here, I put it in parentheses, x plus 3, on the argument. So it's with the exponent on the argument. Okay? Everybody see that? So pause if you want to and look that over a little bit. I do have a cheat sheet for you that I will put on the Google Classroom in a couple days. Okay, so here is another one. This is showing you the horizontal movement. This is a movement on my x, on my argument, so therefore I know it's horizontal. Horizontal's wacky and goes the opposite way, so this is going to be left 3. So there's that equation right there. Okay, this one is on the argument again, so I know it's horizontal, and it's a minus, so I'm going to go right 3. And that shows you that equation there. This one in the middle was my original basic equation. So you can see that I went left here and right here. Okay, so on page 146 in your textbook, it has this example. And so it gave you the basic equation. Notice that this basic equation isn't so basic. And it's telling you, by saying this is the new equation, and it's telling you to get the new line, all you do is do this to the old equation. Well, I know that since it's only affecting the argument, it's telling me to move left 3. So I'm going to take any points that I can find and move left 3. And you just go look for points that are on crosshairs, and we're going to move left 3. And then I draw my new line. Now, that's the new line, but how do I get the equation of the new line? Well, if I'm really good at slope-intercept, I could figure that out. But what I want you to think of is you're going to take the original function, the 2, and we're going x plus 3, so we're going to go x plus 3 minus 1. So we're going to do exactly what it said to do there, only affect our argument by putting that plus 3 with our x. Now we're going to distribute. We get 2x plus 6 minus 1. Simplify. The t of x is 2x plus 5. So now I'm going to check out my graph to see if it matches. Yep, my y-intercept is 5, and my slope is up 2 over 1. It's the same, so I've got my new equation. So that's how you would find the equation using the information that they gave you. Okay, you would apply it to the argument only. All right, so now we're going to talk about vertical translations. Everybody loves vertical because we know that up is plus and down is minus, which makes it a little bit easier to figure out. Okay, so let's look at this and see what we notice about this. So again, here's our basic function in the middle, and this one is plus 3 from there. So you can see these are by 2, so it went up 3, okay? And then this one is minus 3, so we go down 3. Notice that how they write that. It is not on the argument anymore. It's not in here with the x. It's outside. So a vertical change is shown by affecting the whole equation. Affects the whole, the whole equation. Okay? So that's why they put the x in parentheses, because then it shows you that it's a vertical change. Okay? And it's logical. Down is negative, up is positive. Okay, so exponential graphs, again, it's easier to show these. So again, if it was horizontal, it would be on our argument, but this is not on our argument. It's next to, it's outside, away from it. So right away I see that it's a vertical movement up 3, a vertical translation up 3. This is a vertical translation down 3. Okay, so you can see it's completely separate from the exponent and from the argument. Okay, remember x is the argument. Okay, so let's, and if we were going to write it in terms of the original function, so if I wrote s of x, it would equal h of x plus 3, because I took this equation, which was the h of x, and I added 3. And the t of x would be my original function, h of x, and it would be minus 3, like that. So that's writing it in terms of the original function. Okay? Okay, so this is the same problem that we had before, only this time, look here, it's saying that take the original function and go up 3. And we know that because it's separate from the argument. It's not next to the argument, so we know it's a vertical movement. So right away we know it's plus, so that is up. So if we wanted to graph it, we would just graph our original line and take every point and go up 2, 3. There's our new point, and here's another point. Let's see, right here, 1, 2, 3. And so now we've got enough points to graph our line. Okay, so now that we've done that, how do we get the new equation? Well, remember that we take the original equation, the 2x minus 1, and since it's vertical, it doesn't affect just the x, so we're just going to add it on to the n. Then we combine our like terms and we get the g of x equals 2x plus 2, and now we check to see if that graph works. So where's our y-intercept? Yep, it's right there at 2, and is our slope still 2 over 1? And it is, so we've got the new equation. Okay, so this last page is just to help you get in your mind what's happening. So remember, if it's on the x, it's going to be a horizontal movement. If it's plus, it's left. If it's minus, it's right. Okay, I'm just giving you all these little hints here. If it's separate from the x, we know it's vertical, and plus is up, and minus is down. So let's look at this one. This is an exponential. These are all either linear or exponential. So this one is on the argument, so I know it's horizontal, and it's a plus, so it's left 1. Okay? This one is not in with the argument. It's not in parentheses, so I'm going to say this is a vertical. This is linear, by the way. Okay, this is exponential. And this is linear, and so it means it's vertical, so it's up 4. Okay, this one is on the argument. This is an exponential. So I'm going to say this is horizontal. And since it's minus, it's right 1. Okay, this is a linear. I can tell that right away because if I distribute it, it would be 2x minus 6. But because it's on the argument, I know that it's, this is linear. Just want to make sure you remember. This is a horizontal movement. And it's right because it's minus. So it's right 3. Okay, this one is exponential. And because x is my exponent. And because it's in here with the argument, I know it's horizontal. And it's minus, so it's right 2. So you can stop this and try the next 5 if you want to, or you can keep going with me, but you need to decide if you understand this yet, okay? All right, so over here, I know that this is exponential, and it's on the argument, so that means it's horizontal, and it's plus, so that means it goes left 5. Okay, these are horizontal translations. I haven't written the word translation out, but all of these are translations. Okay, and what we're learning about with 3.6 is transformations. So they're transforming the line, but this is the specific case of translations which just go left, right, up, or down. Okay, they don't go diagonal, just left, right, up, or down. You might have 2 of them, so you could go up and down, but that's in another slide. Okay, so this one is not in with the x. We don't have parentheses, so right away I know it's vertical. Minus is down, so down 7, and this is linear. Okay, this is exponential. I know that because the x is the exponent, but because this is separate, I know it's a vertical, up 1. Okay, again, this one's in my argument. This is an exponential, so I have to say this is horizontal, and negative is right, or minus is right, so right 9. And this last one is, again, linear. I can tell that when I distribute it, but the argument is being affected within, so it's in parentheses, so this is going to be a horizontal movement, and this is linear, sorry, and because it's plus, it's left 4. So you might want to study that and think about it. If I had a quadratic, I would know that if it was 2x squared plus 1, that would be up 1. If it was 2x plus 1, whoops, I forgot the 1, squared, that would be left 1. Okay, this would be horizontal, this would be vertical. So look at that. It affects the whole thing, the whole equation. This affects just the argument. So that's what you want to look for in each of these cases. Okay, so that's the first part of 3.6, translations. So go work on your homework. Use this page if you need to. Do a screenshot, and then you'll have the hints there for you.